Hey, so this is an example of Tableau we did with Telstra. So this was last year. So their problem was like they have like mobile station huts, and the main issue they have was they have an air conditioning system and like a normal window system, but it's not automated. So they actually had to manually. So there are only 3 options on the air conditioning. If it's like over 30 degrees, then the air conditioning steps in.
36.
Oh, 36 degrees, yeah. So that's only like one option. So they only have like one if statement or something. So what we try to do was, we can actually like change the air conditioning's temperature, like 20 degrees, 21, 22, 23. But as you know, every single temperature change increases energy consumption. So our aim was to not cause problems to the mobile hut station, but at the same time reduce energy consumption and temperature. So this is the dashboard that we developed. Well, there's 3 dashboards. So, is it loading? So this one's actually the algorithm in play. So the data that we used is, I think Kensington, but all the Bureau of Meteorology data, the temperature, humidity, I think, temperature, humidity, the UV, I think, precipitation and all of that. So we use like 4 different factors, and then we can predict. We developed a similar system to DeepMind, which is the original system called policy networks. So we use policy networks to create these predictions. So you can scroll so you can change the different configurations, like outside temperature, that's outside humidity and outside temperature. And if you change those different settings through the algorithm, you can actually see approximately should you open the fan or not. So opening the fan, so these are the different speed levels. So 0 means close, don't worry about negative 0.2. But the 1.4, I think that's the maximum speed of the actual fan. But 1 just means open. And as you can see, and the other scale, so this is the fan scale. The fan scale is the orange dot, the orange star. The air conditioning is actually the blue one, the blue circle. And then the scale for air conditioning is how many temperature should I do minus from the actual current temperature. Where did it go?
Yeah, it's because you don't have a data system.
Yeah. So for example, the air conditioning says minus 0.4. What it means is that if the outside temperature is 16, the air conditioning temperature should be set at 16.93, something like that. So that's what the number means. And this is in Tableau, so you can actually create data, dashboards in Tableau. What's the other one? So this one's over the time. So Tableau, you can also do time series. Also, I forgot to tell you, like, what's the whole point of Tableau? You can do this. So Tableau is free for students, but the whole point of Tableau is that you can visualize data easily. It's just drag and drop. I will probably show you later. But the whole point is you can create all of this cool stuff and sliders and time series stuff. Just click, click, click. There's no programming needed. If you want to put Python or R, it's integrated inside if you want to use it or not. It's up to you. But so these are just, the top one is average fan, so the fan speed. This one is the average air conditioning plus the average humidity and temperature. So that's just a multiple graph. The gray line is the gray field thing is the air conditioning temperature. The blue and the green, the blue and the red ones are the temperature and the actual humidity. This one is the outside temperature.
Versus the outside humidity.
Yeah, versus the outside humidity. And this one is average cost. So that's actually the cost for the energy. So I think what we managed to show Telstra was that we can reduce total cost by approximately 50%, which is millions of dollars of savings. I can't remember exactly the numbers, but they spent like
I believe it was 7.
7?
7's the figure you were throwing around.
7 million. Oh yeah, approximately $7 million. If they implement the system. Is there?
No, you've just got dupes. I don't know what the third one is.
What's the third one?
there was supposed to be a first.
Oh yeah, one of them is time series. So that one's time series through time, and this one is just normal statistics. So yeah, you can click like which month, like January, February. Wait, go back up. If you click like July, during winter. Oh no, up. No, yeah, that one.
Oh, sorry, yes, there.
July. Click like July. That's winter. So winter will look a bit different. See, winter is extremely different from summer. As you can see, I think the blue is fan. No, sorry, this one. The grey one is air conditioning. You can see it's never actually turned on. It's probably like up to here. It's just, that's because the temperature was too high. But as you can see, the air conditioning is actually never turned on during the winter, which actually kind of makes sense, right? And this one's just a cyclical trend of, I think that's temperature. Yeah, that's temperature. But as you can see, the cost is very low, right? Because you can just open the windows in winter. There's no point of opening the air conditioning. But sometimes you can still see these like little gaps. You still need to open the air conditioning sometimes because in the server room, the heat it can't actually escape. So you have to use some sort of air conditioning system to remove the heat. But yeah, in winter, how about summer? Let's try. Oh, not summer. What's another? Spring or something? Or I don't know, any other. Loading.
There you go.
Oh, okay. So in spring, where's that spring? Yeah.
Yeah, this is October.
So it's still kind of low, right? You don't actually need to open the air conditioning all the time. Only sometimes, right? You can see these peaks, but it's not that common to open the air conditioning system. You can see the cost is very low. But for example, we showed you January at the beginning, which was summer. You actually had to open the air conditioning a lot, right? I think before January you could see a big spike in air conditioning. But yeah, that's kind of how, it's just showing what Tableau can do. Shall we show them?
Yep. Okay, let me go here. First thing I'll kind of go through is a couple of the example ones they give. There are, how many? There is, just trying to figure out how many graphs they have built in.
Oh,
What? 8.3, 24. 24 individual graphs that you can play around with, which go from everything between table data all the way to, as you can see, a picture of the world spatial map. So this kind of little example one that they kind of do is actually really good. It goes through a couple of the different things that you can kind of build with Tableau through pure drag and drop. I believe some of this actually has R built behind it, which you can incorporate, so you can run R script lines, and I didn't know you could do Python.
Yep,
but
putting you on
Python. So pretty much all this is right here is a picture of the UK, and this data set is a hospital map, and it's basically how many beds and the satisfied section, and that's just the color. So the size of the circle is the size of how many beds, or the count, and the satisfaction rate is the different coloring system. So it's quite a nice map to kind of go through. It's a good way of visualizing data that is geographical. And there you can see an example of the table. Pretty much just.
I didn't code that in the map. Is it using GIS, I guess, information?
So you have latitude and longitude, and then you click. So if you click Show Me,
Yeah, sorry.
after you plot latitude and longitude.
Give me a second. Unhide this. Where is it? There it is. So yeah, so your columns and rows are your longitude and latitude values. This one uses averages, but you could actually use count or sum, and you could use sum as well, because the value will just be an independent value. Because I'm pretty sure this data is aggregated.
Try it. Yeah. You can click that and do dimension.
So you can.
Just do dimension. Try dimension, and then the other. Yeah, click that, and then do the bottom one also dimension. Okay, so it's not big. Yeah.
Yeah, no. So all the data is aggregated. So you basically plug in a latitude and a longitude, and then this is like what you would call your marks area, or in this way the system. So they have a hospital name, but as you can see over here, it's literally nothing at the moment. And then you have your size of your circle, which is based on the sum of the hospital beds, and the average overall satisfaction, which is the color base. And you build these all by just literally dragging and dropping. So you can do that, and you can see it. This is basically, the size tells you the satisfaction rate, which doesn't really seem to kind of work. But anyway. So it literally is drag and drop. But yeah, no, the maps just use latitude and longitude. There are two map systems. One is a geographical map system, and then the other one is, I think the other one is actual like location specific. So like if you were to put in a latitude and longitude, it would fix it within a state system. I'm not sure if this one has it, but let's just check mine. I don't think it does. One of them do, I can show you. But yeah, no, it's all pure latitude and longitude input. So Tableau does all the back end of this. One thing I will say that Tableau doesn't have is that if you don't have a graph in here that you can't use anything like JavaScript or anything else to input it. Like Tableau is a kind of fixed source. You can only use what you're given. And even then it's a little bit play around-ish. Let me just open a new one and I'll show you the other map, which is kind of cool, because they do that one. Quickly. That's in this one, I think. There we go. So that's the other sort of map, and basically the same thing goes again. Let me just hide this. You put a latitude and a longitude, and it will generate state systems. And so it kind of gives you this nice little graph where you can actually go and look at geographical state systems, and this is showing us profit ratios, I believe. Yep. Yes, which is pretty cool. So the different color system ring is basically profit, I presume closer to red, less profit you have, closer to dark blue, the better the profit you have. Yeah, that's pretty cool. Anyway, so that one. We have these, what we would call, I don't know why that shows up as a prime. We have these scatter graphs, which are pretty cool. Tableau has like inbuilt analysis into it, which includes trend lines, logarithmic lines. Not sure. There is. If I go here. There we go. So we have box plots, medians for our summarize, and then for our total we have trend lines, forecasting, a clustering system that I did not know about, and I'm pretty sure that's it. And then the custom side is where you can just play around a little bit with the reference lines and distribution bands by setting your own functions for them, instead of using a linear transformation, which I believe is what trend lines is. Pretty cool. So that's some of the inbuilt stuff, and that's what those graphs are. What else do we have in here? Oh, we do have a geographic. So that's geographic. It's London housing. That. So again, we have a latitude and longitude, and then just a couple of systems. Which is pretty cool. And then we have our line graphs, which is the other really cool thing. Line graphs and scatter graphs are the only ones which you can use analytics from the trend line systems on, I believe. And then you just have all these stacked and overlay graphs, which are pretty cool as well. What's that other than stack graphs? That's the and then we have this other graph, which is actually pretty cool. It belongs to this thing over here, which is a highlight table. And the highlight table basically just, it has two forms. You can do it by color. So this one's distributed by date. And then the color is based on, what is the color based on? I don't know what this one is. Overall conditions, which I don't know what that is because I don't do this stuff. But, and then you can also play with size, so you can get these kind of cool distribution graphs if you ever want to show off your data in a nice little way of about its distributions and how much content or counts there are in it. I'm not too much sure there is anything else. Cheers. That's pretty cool. So that's just the regional map with some line systems built into them. And so basically what they've done is they've placed all the stations around. The size of the circles are built by line, by how much usage they have. So the bigger the circle, probably to do with more things, you can probably see, but it's these usually less central, so I'm going to assume that's probably central area, what we would consider central area, and then the lines are just built in through the multiple fields section, and basically it just connects all the dots. They're just straight lines between all dots, and you have a system, it's split off by line. So line will be just a type, so I presume these all have a variable type, which just says what type of line they are, whether they're the Jubilee line, and then it just links them all up together, which is quite nice. So there's a lot of really cool things you can do with Tableau, and it's pretty easy to use. Okay. Maybe I can just do this. The way Tableau works is it's got a couple of nice things. You can use, there's a version of Tableau called Tableau Server, which works with the cloud, so you can have your data on the cloud. Sorry, that's Tableau Online. Tableau Server is where you run it on the server, which is pretty cool. And then it has all these other connections to Microsoft, MySQL, Amazon. I'm pretty sure Azure is in there. What else is in here? There we go. So it has a pretty substantial database connection if you're pulling your data from databases or cloud. And then it also has local file systems. You have your Microsoft Excel, JSON thing. I will be using text. I believe I downloaded something for this. Wait a second. No. Okay, let me just download something.
What's the first one?
No, I don't like that one.
Oh, okay.
It's not easy to download. Well, it is, but
Oh, that's,
so yeah, text file.
no, it's a CSV.
It's a text file.
Oh, no. Oh, yeah, that's fine. Text file and CSV. Yeah.
So I'm just going to use the iris data to kind of show off a couple of things. It's not that big in terms of sparse, but we can do a couple of things like correlation, trend line graphs and stuff like that. So if anyone doesn't know, this is the iris. It basically just looks at species of plants and their sepal and petal lengths and widths. And generally this is just a clustering system, so you basically try to see if you can pick out what the species is based on these four things. Anyway. So first thing you generally want to do is have a look at their thing. So as you can see, you kind of, when you build in the data, it kind of basically tries to pick out what is categorical and what is an actual value, which you can see it's split off. There is actually a third thing called parameters, which comes down here, which you can make your own. And those are the three types of variables in Tableau. And then for each variable you have what's called a discrete or a continuous value, which species is a discrete value. You can change it if you wish, and it's also a dimension. So if we chuck in, this over here, and I want to keep that as a table, we can start, oh, no, it's right over here, and have a look at, actually, it's a really bad way of doing this. So Tableau does this really cool thing called measure values, which is basically just an aggregation of all the values into one box. So if you drag that, what the, oh, why does it do that? That's useless. What have I done wrong? There you go. So that's a pretty good way. It's probably always a start to kind of pull out your data and have a look. This is basically just the sum of all the values for each. We can have a look at averages. There's a nice, really easy way of doing that, which is give me a second. Data. That's a PR. Where is it? Where's the you can select the way it what do you call it? The way it the way it
average.
yeah, like make everything average.
Make everything average.
Yeah, there is a way of doing it. There's a nice way of doing it.
Oh. Okay. I don't know.
There is a nice way of doing it.
Can you try and measure values? Like
No, it's fine. No.
some there.
Oh, there you go.
Yeah, that
There is a
average.
nice way. There we go. So we can have a look at the average of all the values between all the three species, sorry, and all the values. It also inputs this nice little thing called average number of records, which is actually just the count of how big your data source is. You can see the average is 1 there because it's literally just a count of each line. So we generally like to keep that as sum or count, and that'll just tell you the distribution for data. There you go. So we can see that there is 50 lines for each species. So our data is quite nicely aggregated. That's pretty cool. Sweet. And then we can start playing around with all the graphs. So in this right thing I have a show me, and with this current setup of having my values here and 2 dimensions, which are discrete values up in the rows thing, it gives me all the possible options that it thinks it can do with its tables. So I have a simple bar plot, which is that. And it kind of chucks the data around so you can see that it's chucked it all up in the columns. There is a nice way of doing this. No. Is it behind you? How do I switch the columns really easily?
You may transfer this. Oops.
Yeah, there's a way of don't worry. So we have a nice thing. There is a sorry, that's this one here. No, it's not. That was a nice way of switching them around. Anyway, here we go. That's that one. So just a nice way of thing. We can see all the distributions. It's not that nicely set up, but they're basically the number of counts. So we can see that distribution of the number of records is even, which is 50, and then all the other distributions. And then there's a couple of cool things you can do, such as chucking the labels on. So we can see that, that's not how it works. Average.
Also, the aim of the RS dataset is to predict which plant is which. So there's 3 species. So there's the Setosa, Virginica, and the I can't remember the other one. But as you can see, Ben is just visualizing the columns and trying to see, like, as you can see, like, you see this step thing. This step actually means that each of these 3 species have different characteristics. This like not really a step, it's like all look the same. That's not really important. But what it means is that this variable is extremely important. So maybe we can do further analysis on that one and to see whether they can split the data evenly into 3 different classes.
Yeah. So I guess that'll lead me into the second one, which is correlation. So nice easy correlation graph is got the is a nice scatter graph. Okay. I believe I need to
Yeah, done.
those 2 dimensions.
So dimension just means plot, like all the plots.
So
And put the color with
oh yes, sorry. Here we
species.
go.
Yeah.
Yeah, that looks fine. So basically what this shows is basically some sort of correlation with each value, and we can kind of actually pair up and see what things seem to deduce a value for each species, and whether they seem to have a correlation or they don't. In general, petal length and sepal length seem to have some sort of correlation, and probably the best, which you can probably see through here. But if we want to make sure, we can chuck in a trend line. That doesn't look that nice, but it works. And we can kind of see that this data kind of bundles around that, but the rest kind of done. Pretty cool. Anything else you want to say about that?
Oh, the iris.
Yeah.
No, I don't know.
There's not a lot else you can do with this data set.
Yeah, that's not. So, yeah, normally like if I start, I just like randomly do stuff. You just literally just put stuff in. It's like, oh, don't forget not the sum, it's the dimension. Yeah, so this is like when I normally do stuff, I just chuck stuff in, like literally, just randomly, like this, and right, dimension, and then, yeah, so it's kind of the same as what Ben did, but you can like, you know, just, if you want to do multiple dimensions, you can increase the size, you can put the size as an attribute. However, you can see all the sizes look the same, so you have to change the, where is the, yeah, you can just do multiple sizes and stuff. You can also put colors, like, but not actually the species. You can put other variables, like you can see there's like some blue ones in here and here. You can also add, yeah, you can do lots of stuff. Label, you can do labeling. You can just, so it's all drag and drop. Also, you can make dashboards, and what dashboards does is you can drag sheets in, and you can put sheets next to each other, like this. Literally just drag and drop. And so if you just drag and drop into the dashboard system, if you don't like this, these legends, you can remove them. But yeah, you can just drag and drop over here. Oh yeah, okay. And this one, like for example, let's say you want to filter something. So let's say you want to filter by the species, you just add it into the filter. And what you can do with the filter is that you can, I think you can show this, show filter, and then over here in the dashboard, let me put that back in sheet 3. And you have the filter thing. So this filter only applies to one graph. You can see on the bottom graph is changing. But this filter can actually apply to everything. So if you right click, apply to worksheets, all of them, right? And then if you do all of them, the data, everything will change, right? Not just one graph, everything will change. So that might be important for people. But yeah, that's kind of the main gist of Tableau. Don't forget you can also change these sheet names. You can also hide the title if you don't like it, right? Hide all of these ugly titles. You can also make the stuff smaller, right? Oops, too small. If you don't like the colors, then you go back to this sheet, right? And you can change colors, right? The color, so the color's like, I don't know, this color, you can make it that color. And then this one's another color. But as you can see, Tableau is all drag and drop, and you can do whatever you like. If you think you can do it in on paper, you can do it in Tableau, right? So I've kind of made some sort of, you can also delete all of this if you don't like. Yep, quit by. Yeah, so that's kind of the main gist of Tableau. Yeah, we have to move to another room. Yeah, but that's, yeah.
Quick question. How do you connect this to like Python and stuff?
Python and R. Okay.